right, good day, geometry. We are going over PO41, which is another way to find sides of right triangles. Vince, turn around, please. Legs on the desk. This entire unit is basically dealing with finding information about right triangles. And first, we talk about the Pythagorean theorem. What do you need to know in order to solve for an unknown side using the Pythagorean theorem? Kylie?
Two sides.
The other two sides, right? This would be something that you could use if you only know one side and you have one of these special 45, 45, 90, or 30, 60, 90 triangle measures. Okay, and if we're talking about 45, 45, 90, or 30, 60, 90, what are we talking about?
A triangle.
Yes, but what do the numbers 45, 45, and 90,
Right
30, 60, 90
180.
refer to?
180.
Right triangles, angles. Okay, so the 45, 45, 90 triangle theorem. If you've got a triangle with angle measures of 45, 45, and 90, first of all, what type of triangle is this other than being a right triangle? Aiden? Isosceles, because it has those two congruent angles there. So what do we know about the legs of a 45, 45, 90 triangle? They are the same, right? If you remember talking about isosceles triangles, the base angles theorem, because this is isosceles and 45 and 45 are those base angles, those congruent angles, we know that our legs will be the same length, and we'll just call that n. Okay? Whatever one leg is, the other leg is the same. The hypotenuse, then, is whatever the leg is times the root of 2. Whatever the leg is times the root of 2. So, if I give you a 45, 45, 90 triangle, and I tell you that one leg is 8, without using the Pythagorean theorem, and really without using any math calculation, if you memorize kind of this relationship, you are then able to tell me what the other leg is as well as the hypotenuse. No.
The other leg is 8. What?
And the hypotenuse is?
16.
Not 16.
11.3137085.
Which is equivalent to 8 root 2.
What?
Okay? Again, notice knowing the length of a leg really gives you everything, because if you know what n is, you know the other leg is the exact same, and whatever that value for n is, it's the coefficient to root 2, which will be the measure of the hypotenuse. Okay? So if n is 8, then 8, 8, and 8 root 2. The reason why goes back to the Pythagorean theorem. I can do it up here. Let's say that, let's just use 8, right? If we were to prove this using the Pythagorean theorem, and let's say that we didn't know C, if we knew the legs were both 8, but we didn't know what C was, we could use the Pythagorean theorem to say C squared is equal to 8 squared plus 8 squared, right? The length of the legs equals hypotenuse squared. Well, 8 squared is 64, and that would mean that the hypotenuse squared is 128.
Do we have to write this down?
No, you do not. Ellen asked for a proof, so I'm proving it. Okay. Now, to get C by itself, of course, we have to root both sides. And so C, the hypotenuse, is the root of 28. Thank you. The root of 128. If we were to simplify this, what's the largest perfect square that goes into 128? 64. How many times does 64 go into 128?
A lot.
That's how we got to 120 in the first place, right? Adding 64 plus 64. So if we break this up into the root of 64 times the root of 2, we break it down to 8 root 2. Right? This will happen every single time your legs are the same length. Whenever you have a 45, 45, 90 triangle, because it's isosceles, your legs have to be the same value. If you work through the Pythagorean theorem, this will happen every single time. So where ultimately you'll end up with whatever n was, whatever you started with as your value for the leg, is the coefficient to root 2 for the hypotenuse. Yeah. Yeah. So in a 45, 45, 90 triangle, okay, because it's isosceles, you know the legs are the same. We'll call them n, boys. And then the hypotenuse will be whatever that length of n is times the root of 2. So in this first one, I gave you 8 as the length of a leg. You know the other leg will also be 8 because it's a 45, 45, 90 triangle. And the hypotenuse has to be whatever that leg length was, in this case 8, times the root of 2. So let's do another one here. If I give you another 45, 45, 90 triangle with a leg length of 11, what would the other leg be, Catherine? 11. What would the hypotenuse be, Anthony?
11 the root 2.
11 times root 2. Okay. If I gave you a 45, 45, 90 triangle and I told you the hypotenuse was 20 root 2, what would each of the legs be? 20 and 20. Right? This relationship, this ratio here will be true for every 45, 45, 90 triangle. Right? 30, 60, 90 triangle is another special one. And obviously in a 30, 60, you've got one angle smaller than the other one. So I'm going to draw it so my 30-degree angle is more up on the top here. Okay, we'll label this 30, label this 60. Here's our right angle here. The side opposite your 30-degree angle, so the shortest side of this right triangle, is going to be your n. Okay. Now the relationship between the short side and the hypotenuse of a 30, 60, 90 triangle is that the hypotenuse will always be double what the short leg is. Okay? Which seems kind of counterintuitive because you think, well, wait a minute now, 60 is double 30, so why wouldn't the long leg be double whatever the short side is? Fortunately, it's not how it works. The hypotenuse is double the length of the short leg. The long leg is whatever the short leg is times the root of 3.
What?
Yeah. Yeah.
That is dumb.
Well, it's not dumb. It's
What?
just,
You could have just
Right?
had it be the same.
And so this ratio, these values will hold for every 30, 60, 90 triangle. So if I give you a 30, 60, 90 triangle, and I'm going to label my 30 and 60 here, as you can definitely tell which leg is the short leg, which leg's the long leg here. But if this is 10,
20.
the hypotenuse would be
20.
2 times n, right? If my short leg is n, the hypotenuse is double that, 2 times n. And my long leg, 10 times the root of 3. Whatever n is, whatever my short leg is, the long leg is that same value, but times the root of 3. Okay? Isn't this fun?
No.
Oh, okay. You're the first class in history not to think no.
No.
What you need to be careful with a 30, 60, 90 triangle is that sometimes it might be like rotated a little bit. So if your triangle looks like this, right, you've got to pay close attention to which angle is your 30 and which angle is your 60. Because that determines which leg is n and which leg is n times the root of 3. Right? If I tell you that this is 16, I've given you the hypotenuse, which would mean the short leg is 8, half that, and it means the long leg is 8 root 3. Okay? Initial questions. Can this go on a help sheet?
Yes.
Should it go on a help sheet?
Yes.
I would definitely think so, yes. Okay? I would definitely think so, yes. All right, let's go down to some more practice down below here. Here are 4 of them. Just in your tables, at your tables, I'll label this 45, 45, 90. I'll label this one 45, 45, 90. I'll label this one 30, 60, 90. And I'll label this one 30, 60, 90 as well. Go ahead and just take a minute and fill in those missing side lengths using those ratios. Check with the neighbor or work with the neighbor. If you've got questions, I'm here. Mr. Lincoln's here as well. Fill in those missing values for A and B or C.
I do it right.
Good, good, good.
Oh wait,
Wait,
do
do
we
we
round
round
our-
our, Mr. Schultz, do we round our number to the nearest 100?
Good. Leave it in root form. Don't put a
Oh, shit.
decimal. Yeah, leave it in root form. Yes, it would be that. Yeah, don't write your answers as a decimal. Leave it
36.
in root form.
What do you mean?
So instead of multiplying 10 times root of 2, just write it 10 root 2.
Hey, don't do that.
Instead of multiplying 10 root 2, write it decimal. Just leave it as 10 root 2.
That's it.
Yep, there you go. You are.
How do I do this?
So the hypotenuse. Yep,
What's the word of six?
there you go.
Actually, it's really close.
Don't take the root of 6. Leave it in root form. Yeah, do not be using decimals here. Leave your answers in root form. If 10 root 2 is your answer, leave 10 root 2 as 10 root 2. Because if you put it as a decimal, then you have to round it. It'll be less
Wait,
accurate.
what about? Is this actually gonna be on a test like this?
Yes, pretty much.
This is light work, buddy.
We're heading to that
Seven
one.
Is my answer so good? Do I do it like that? Oh, thanks.
Oh,
What was this?
what is it?
What? Yeah. Why is that root 3? I think I'm gonna have to guess this one.
Anyone have any questions?
The next page.
Yeah, that's
Not on the back page yet, or the second page. We'll talk about that. Okay. The second page brings back your knowledge of square roots. Last year, PO41, CO62. And so we'll talk about those together, just kind of get those lights flickering. But any questions on what you needed to do here?
No.
Or your answers? These are both 3. Down here, this is 10. This is 10 root 2. Again, don't multiply 10 root 2 out. Leave it as in root form there. Because if you write it as a decimal, you have to round it. You lose accuracy. 10 root 2 is the exact value. This one, 30, 60, 90. Our short leg is half the hypotenuse, so that's 4. Our long leg is that same number, 4 times the root of 3. And then in the bottom one, I give you the short leg. That's kind of dumb. This is 8. This is 4 root 3 again. Something tells me last year about this time I said, I should fix that for next year, and I never did. But I should fix that for next year.
Wait, why? What?
Oh, because it's this exact same triangle as the one you just solved on.
They don't test
Okay,
What? Oh, it is.
it
Yes.
is. Yeah. The second page. So rather than drawing out a whole bunch of 45, 45, or 30, 60, 90 triangles, I instead gave you kind of a base ratio one, and then a chart saying if A is 7, what's B, what is C? If B is 11, a new triangle now. If B is 11, what's A, what is C? A new triangle. If C is 10, what's A and what's B?
This makes no sense.
Okay. So let's do the first one. If A is 7, and you can draw it down below here if you want to. If A is 7, what does that make B and what does that make C? Rowan.
B is 7 and C is 7 to
Yeah. B will also be 7, and C will be that value, 7 times the root of 2. Okay? New triangle here. If I tell you that B is 11,
C is 11 root 2.
then what is
B
A?
11.
Yes, draw them out. It's a triangle.
We don't have to. I do
It's
can.
the minimum number of sides for a polygon.
Is it weird how big is the triangle? We can just.
Just start crying.
Sorry, things are so challenging. If B is 11, what is the value of A?
8 or 11.
Also 11. If B is 11,
11 squared.
what is the value of
11
C?
squared.
11 root 2.
Then how do we do the next one? 10,
Well, good
10,
thing
10.
we're there now, right? Okay. So this is the gist of what you're doing here. I give you one side in a new triangle. You solve for the others. So what happens in this third one here, and I'm going to give myself some more space just because I'm going to need some work for the algebra. So we're going to clear the ink. We're going to move this up. And we're talking about this third column here where your side length is 10. And that 10 that I give you is the hypotenuse, which is where our root's supposed to be. So, what do we do here? Okay, Arlene.
You put 10 over the root of 2 and you simplify that.
Okay, so what Arlene's saying here, where she's saying take a 10, put it over the root of 2 and simplify it. Where she gets that is, remember that the 10 is equal to the n root 2 side. Right? In a 45, 45, 90 triangle, the hypotenuse is the n root 2 side, and I've told you that that side length is 10. Everyone follow me so far? Okay, flip back to the front page. You saw your initial 45, 45, 90 triangle that we drew. The hypotenuse, we wrote n root 2, right?
Yep.
Okay? Same reason why you got 7 root 2 here and 11 root 2 here.
Yep.
Okay? So if 10 is equal to the n root 2 side, and we want to solve for the leg, what variable are we solving for? N. Right? The legs are the n sides, which means that if the hypotenuse is equal to 10, which is the n root 2 side, we can use a little bit of algebra.
5.
Divide both sides by root 2,
Yeah.
and that's going to give us whatever n is. Okay? Now it's not root 5, because remember back to our rules for roots.
Oh.
Why is it not root 5?
5 divided or 10 divided by 1.4.
Oh, it's 3 root 2.
Why is it not, why can't we say this is root 5 here?
It's 7.
Shh, stop saying things.
5 isn't
Because our numerator isn't under a root, right? We can't divide a non-root value by a root value by taking 10 divided by 2. We also don't want to round root 2 to be 1.4, because if we round, what have we lost?
Most
Accuracy.
Well,
Okay?
we're wrong.
So we do want to leave this in root form, but remember, we can't have a square root as the denominator of a fraction. So what do we have to do?
Square bowl.
It starts with an R.
You got
Round. Round.
Ratio.
Round.
Rationalize.
Ah! Well done!
It's only because Kylie said it.
Well, then brilliant for you, okay? But we have to rationalize. And if you remember how you rationalize, is you multiply the fraction by the root you want to remove over itself. Why? Because what does root 2 divided by root 2 equal?
I'm lost.
1. Anything divided by itself is 1. So we're not changing the value of the fraction, but in our denominator, what happens when we multiply root 2 by root 2?
You get 0.
Don't get 0. Don't get 1.
You get
2.
You get the root of 4,
Oh no.
and the root of 4 is equal to 2.
I'm lost.
So I hear what you said too.
Okay. This is PO41, part 2 from last year. Hold up.
You don't remember the data? Sounds like we did it.
Must not have. Even though someone said rationalize. Anyway.
Oh,
Ellen.
I'm still not getting this.
Wait,
Even the first part, like 10 equals n root 2.
Well, the hypotenuse of a 45, 45, 90 triangle is the n root 2 side.
Yeah. So why does 10 equal n root 2 though?
Because I've told you that this C side, which is the n root 2 side of a right triangle, is equal to 10.
We're not paying attention.
Okay? So this 10 equals n root 2 comes from the table, and that's the side that I gave you.
I see.
Right?
Get the top though.
So, hold up.
The top.
So what we did was we set 10 equal to n root 2. Damien, if you don't get it, look up here. We divided both sides by root 2 to get n by itself, because n is what the legs equal, right? We solve for n, we've got the value of the legs. Okay? So we divided 10 by root 2. 10 over root 2 doesn't work out evenly, so we have to rationalize. We multiplied by root 2 over itself, because this equals 1, so it doesn't change the value of the fraction. What it does is it eliminates the square root from the denominator. And then in our numerator, 10 times root 2, we can't write that as a root 20, because one's under a root, the other one isn't. So we just leave it as 10 root 2 over root 4, or 10 root 2 over 2, and we're done, right?
No, we're never done.
We're never done,
I
right?
told you that.
What can we do here? How can we simplify further, Kylie?
Divide 10 by 2.
We can simplify our coefficients.
Is it actually
10 divided by 2 equals 5 root
I had
2
that
over
the
1,
whole
or
time.
just 5 root 2.
I said
So
5.
because those sides are 5?
You just forgot the root 2.
The other sides are 5.
I could've
root
done
2.
that.
Oh, 5 or 2.
What?
How?
I don't understand.
Hey, because you
Okay.
How do you get 5 or 2?
We get 5 root 2 by simplifying our coefficients here. 10 divided by 2 equals 5.
Well, what about our
The root 2 we can't simplify, we can't do anything with.
So it just gets
Just gets to come along for the ride. Exactly. Rowan,
So could you just divide it by 2? So like if it was 12, could you do
Yep.
just 6 root 2?
Yeah.
what do you think?
Yeah.
Yeah.
No.
Try it. Did you try it?
Yeah.
Does it work?
I already did. It worked.
Figure it out.
I tried it. It worked.
Good.
I'm doing it. Hey, be quiet. I'm doing it on all mine.
All right. Let's pause on this. We'll finish it up tomorrow. No homework for tonight. Be working on Khan Academy. Be working on your math pack. Turn it in. And we will discuss tomorrow. That's our math, folks.